Hello, and welcome to this Australian Biocommons webinar. My name is Georgia. I'm the Australian Biocommons BioCloud Training and Communication Officer, and I will be your host for today. This webinar is part of a series in which we share useful information about the latest digital techniques, data, and tools that are available for the life science community. Each month, we hear from local and international experts who present a bioinformatics topic that will support Australians to deliver their best environmental, agricultural, and medical research. You can keep up to date with the latest Australian Biocommons news and events via the channels listed on the screen. Before we begin, I'd like to take a moment to acknowledge the traditional owners and their custodianship of the lands on which we meet today. In my case, this is the Gadigal people. We pay our respects to their ancestors and their descendants who continue cultural and spiritual connections to country. We recognize their valuable contribution to Australian and global society. Today, we're thrilled to welcome Dr. Fotis Psamopoulos to speak to us about DOME, a set of guidelines for ensuring robust evaluation and reproducibility of machine learning models in life science research. Fotis is a senior researcher at the Institute of Applied Biosciences at the Center for Research and Technology Hellas in Greece. His research interests lie at the intersection of bioinformatics and machine learning. Fotis is co-leading the Elixir Machine Learning Focus Group, which produced the DOME recommendations, and he is active in training efforts and initiatives. He is on the Elixir Training Program Executive Committee. He is co-author of the Greek National Plan for Open Science and coordinates the European Virtual Institute for Research Software Excellence project. Welcome to the webinar, Fotis, and I'll now hand it over to you to start the presentation.
Thank you, Georgia, for the very nice introduction and for the invitation to present here in this audience. The webinar today will comprise of three sections. I will start with an overview of what the DOME recommendations are, hopefully providing some quick context. And then I'm going to do a quick presentation of a framework, a service that is combined with the DOME recommendations. These are going to be slides prepared by the other colleague of Machine Learning Focus Group, Professor Silvio Tosado from Italy, University of Padova. Unfortunately, due to the time difference, it was not possible for him to actually do the delivery, but he was kind enough to give me the slides. And the last part, it's going to be a pre-recorded session from Scott Edmonds from GigaScience, which is one of the adopters of the DOME recommendations themselves. So that's kind of the quick overview of what's going to happen. So without any further ado, DOME recommendations. So I'll start with the obligatory big data and AI stuff, because I'm sure everyone has seen that a million times, so 1,000,001. There are a lot of articles out there, right, talking about big data, AI, transformation, the impact that this will have, which is quite true. There is an argument against that. It definitely has an impact, AI and machine learning. Focusing a bit on life sciences, it's easily seen that machine learning is basically used and applicable in all aspects of biological research, from the very impactful AlphaFold and the impact for protein structure prediction, to applications of on cell notation on single cell, to fluxomics and metabolism. Applications of machine learning are evident across the board. We can try to be very much more specific on that. Although it's not really up to date, as you can see, the bottom graph, it ends in 2021. This is kind of a quick overview of machine learning publications. It's a very restrictive view because, as you can see from the legend below, they are very limited in terms of topics, but it gives an overview of, well, what we all expect, that there is an exponential growth of publications out there that actually use and deploy machine learning. However, that's not the best case scenario because machine learning is still a tool. And because of the number of publications, there has been a very distinct effort to do a quick assessment, what is actually happening, how things are proceeding. And a few years ago, well, almost 5 years ago now that I see it, there was a kind of a call saying that if we review all these publications, we find some worrying results. Simply put, look at the publications themselves, 20% of them did not apply any evaluation of the machine learning process itself, which is stunning. It's equivalent of I'm doing a wet lab process and actually have zero information about what is my control, how I assessed the efficiency of my wet lab experiment. And this 20% is kind of across the board. If you try to correlate that to the background of the co-authors of these publications, it might rise to as much as 34% when you're looking at publications where there were no computational co-authors of those. This is easily translatable as this, that this huge corpus of publications, we are talking about a significant absolute number of publications that have been producing new knowledge after peer review with absolutely zero information about the data and how these have been effectively introduced into the method, no cross-validation, my personal favorite, no statistical testing. It's essentially, I applied machine learning and my new knowledge is this one. Basically, that's it. So no information whatsoever. So how would I trust this? Why is this good enough science? So for this reason, recognizing this kind of challenge, Elixir, which is the European Infrastructure for Life Sciences, put together kind of a ad hoc group called the Machine Learning Focus Group in order to review a lot of the activities around machine learning. Beyond standards, which I'll be talking about soon, some other activities were around benchmarking, reproducibility and fair, training for machine learning itself, and how this can be connected to the various perspectives and efforts within Elixir. But the clear kind of focus and the first thing that we try to tackle is essentially we are a huge consortium. We represent a lot of different organizations and countries. How about we figure out at least a common understanding on how we want to deal with machine learning? So with that, our first kind of output back in 2021, I think, was the DOME recommendations. So DOME stands for Data Optimization Model Evaluation. It's kind of an acronym. And in practice, it's the full title you've seen there. It is a set of recommendations on how to do effective reporting. It's not about evaluating or saying whether a particular effort is good or bad. It's simply put, what is the minimal information I need in order to, me as an expert, make an assessment of the machine learning process itself. So is it sufficient for me to say data is fine? That's the data set. Is it sufficient for me to say this is the tool that I used? That's kind of the main goal of DOME. It was produced by a larger group, so it was a community-led effort, which is also an important aspect of the DOME recommendations, mostly because it has the backing of a community. It's not a group or a small set of people saying that we agree that this is important. It's a much wider set of people who have a vested interest in this field, acknowledging that this is a problem and providing some suggestion on how to deal with that. So in the next few slides, I'm going to go through a bit what the recommendations are, but I would definitely recommend that you check out both the website and the regs that I'll be showing in a bit. So for each of those letters, there's a particular set of questions that is tied to those. For data, we're talking about essentially what is the data has been used to produce the model itself. From the provenance, where did I get the data? How I used the data for the training, testing, validation. If I did that in the first place, what are the overall characteristics? If there's any redundancy, which might have also some insights if you report on that, or whether you have any data leakage or not. And for reproducibility, it's also useful to know whether the data are available, because ultimately, again, I will reiterating this a few times, DOME is about reporting specifically. So if we go to the optimization after the data, this is more about the algorithm itself. What was the process, the method that was used, whether it's a predictor or a meta predictor, if I did any kind of encoding or feature selection of the process, what are the features that I selected at the end, how did I assess the fitting or under or overfitting of the model, which parameters I used, the values, and ideally, again, tying to reproducibility part, if the whole configuration is somehow available, so I can take it away. And this is quite important in cases where your method might take a few million parameters. It's not easy to report on each and every one of them. But if you have a configuration file, it's much easier for someone else to pick it up and rerun it if need be, and if at all possible. Then we go to the model. So if you run the process, you create a model, we need, again, some information. First and foremost, the software. Did you create by it yourself? Was this an existing software? Can I find it somewhere? The last one is one of my pet peeves, because occasionally you have a model that is phenomenally well behaving, apparently, but you have no information about the software that produced this one. Whether the model can be interpretable or not. Is it a black box? Can I understand how the selection, the prediction has been made? And also some broad idea of the execution time. If the requirements of creating the model are having the entire HPC system of a small country and a month of runtime, it's probably not likely that any given researcher will be able to reproduce that. But still, it's something to report and be aware of. And last, evaluation, which was the starting point of the whole process. What is the method that you use to evaluate the model? Did you compare to somewhere else? Did you compare to a different data set, different problem? What is your confidence? What are the statistics that you use to say that you have a very well-behaving model and you are with trust in that? What are the measures that you did use for your performance? And again, as usual, can I have this somewhere deposited altogether so I can reuse it if need be? For the next of the slides, I'm having some examples of how this may filled in with one of the articles from within the group. So you can have an idea of how detailed this might need to be. For provenance, for example, you can see in this particular instance, they're talking about data from PDB, the protein data bank, and some broad idea of how many elements this contains. If it was split, in what form, in what capacity, and also information, as you can see, I did use 0 validation sets. I did the full training, and I had a small percent for the test set. Redundancy, because I had no splits in this particular case, it's not applicable. Again, I'm not saying here whether this is bad or not. It is important to be clearly reported, so when the expert, when the reviewer, when the user, when the researcher looks through that, they can make their own assessment. And of course, the availability, if there's URL, go find it. If there's a license, please report on that. The optimization, again, some quick overviews. I'm going to highlight a bit more the meta predictions because this is always coming as a question when I'm talking about DOME recommendations. DOME is specifically designed for supervised learning. So a rather big-ish category of predictive supervised algorithms include meta predictors, essentially the output of a set of predictors that lead to the next level. Because this is quite often seen in life science applications, we opted to have this explicitly put as a question, just to make sure that everyone captured it effectively. The rest is, as I mentioned before, for anyone who is ever involved in machine learning, pretty much standard questions about how you code the data, if you select any features, if you assess the fitting over or under, if you regularize your data, etc. The model itself, interpretability or not, if I used anything as a black box or not, What's the classification, the output, the execution time? In this instance, you can see it was 1 second per element that was used on a desktop PC, which broadly gives a decent picture of how fast this might work on a realistic scenario. And there's always the software that can be used. And finally, about the evaluation, how it was evaluated. In this case, evaluation was from independent data sets. The measures, the metrics, the comparison against which it was also used as methods, no statistical confidence, and also, of course, no variability evaluation in this particular case. As I'm saying, I'm not talking about good or bad results, good or bad performance of model. DOME is only about what needs to be reported. So with my last slide on the DOME recommendations themselves, what we are trying to achieve now is that a lot of efforts are right now targeting AI and machine learning specifically. And because everyone is rushing to create the next application, the next solution that is AI-based, it's become a bit of a Wild West in terms of how can you learn about it? How can you can trust the information that you're getting? So this need of standards on reporting, on working with machine learning is quite clear, and hopefully DOME is emerging to be one of the stars for one of the standards, at least for the reporting part. It is definitely one of the actionable solutions, which means that it has an output that can be effectively used by others. And it can be used not just by researchers, by publishers, funders, and policymakers. And hopefully you'll see some of these groups presenting at the end of the webinar today. Beyond that, and what we are doing, plan to do ahead, is to try to engage also with others beyond the immediate stakeholders, and also to apply it beyond the supervised learning and the life sciences, because I'm hopeful that at this point you've all understood that none of the questions that were raised was specifically for life sciences. So ultimately, this can be applied to any kind of discipline at the end. However, we need to find the other domains and have an open discussion with them to make sure that this is indeed the case. And with that, I need to acknowledge first and foremost the community of the Machine Learning Focus Group, because that was a community effort itself. And of course, the people that led that, as I mentioned before, Silvio Tosado from University of Padova, and Leila Garcia from ZBED in Germany. I think that kind of covers the first part. I'm going to stop sharing my screen for a second so I can load up the second set of slides, which I'm going to be presenting on behalf of Silvio Tosado, the co-lead, the Fox group, and the next part of information. So I've talked about the standards. The standard is essentially, if I can be extremely simplistic, a piece of paper that outlines some guidelines. However, in order to ensure adoption, what is usually needed is a service, a framework, something that can make life easier for the people who are going to be using the standard. So for this reason, we implemented the DOME registry. This is now being maintained primarily by Silvio's group in the University of Padova as a joint activity between the two Elixir nodes, Italy and Greece. So what is DOME registry? So the main idea is that ultimately the DOME recommendations can be used to annotate a paper. Simply put, that's the idea. It is a set of annotation. It's information that is lying on top of the actual paper itself. So in order to get to this annotation means that we need to take a paper. We're going to have some experts, members of the community, going through the paper itself and actually fill in all this information. And this can be done in many different ways: Google Forms, spreadsheets, documents, but ultimately it is a collection of knowledge at the very end. And it can be used for very many other reasons down the road. So for that, we implemented this online platform called DOM Registry in order to have this curated set of annotation of all the papers according to the DOM recommendations. So this is how it looks like. It is open as well. The link is down there, so you can actually go and look it up. I think since I've used these slides, in this slide represented, I think there are a few more entries now as part of the system. But it's also quite important that you can see there that beyond the actual like overarching statistics and browsing what is in there, there's also the API and also the in progress, which means that people are currently in the progress of curating information based on DOM annotation on planned or existing articles. This is how it looks like, more or less. As you can see, everything is kind of an open field, which has some advantages, but definitely some disadvantages. The advantage is that everyone can put whatever they want in there, and you can have, it can be as explicit or as detailed as you like. The downside is that occasionally you might need to have a very broad response, so it might not be that useful. Ultimately, you can use the level of completion of a particular article to kind of do a DOM score. Again, the DOM score is not as a indicator of quality. I have to be absolutely clear on that. Is the level of reporting that has been done on a particular article. So in this particular case, for the article that you currently see, we are talking about an overall score of 20 out of 21, because essentially one of the fields was not effectively filled in, which created a problem. That's how it lowered the score. None of this information is assessed. So it might be saying that I did zero evaluation, I did zero, I have used the same data set for both training and testing. No judgment on that. It's not the goal of the DOM recommendations, but the DOM registry captures all this information so that experts can review that and make the call themselves. However, the registry is not a standalone thing. It's part of a much wider ecosystem, and this is what we are trying to achieve looking ahead. So the DOM registry, as you can see on the lower right corner, is effectively the place where we keep all this information, but there are people that actually put this information in. And we want to be able to recognize and reward the people that actually put effort in annotating these papers. For that, we're using the Apicurium system, which connects people's with effort, people through the ORCID, more or less, the effort through the number of papers they annotated or helped curate along the way. And this is essentially a scoring system that you can use, kind of a Hall of Fame, how many articles have I annotated? So look, I have a gold medal or something like that, which is a good incentive because you're gamifying the system. But in either case, it's definitely a very clear mechanism of recognizing and crediting people for their effort. On the other hand, the system itself, as you've seen before, it's their open fields. And in some cases, this might, again, be slightly, not difficult, but challenging to understand what the question might be without additional context. So for that, we also connect this to the data security wizard, an instance of that. So we call it DOM wizard, which essentially is a mechanism for the original user, the person who submitted this paper for annotation, to provide initial information on the fields themselves. So this is essentially a wizard that you can click through with questions, elaboration on each of those fields that help guide people filling this annotation itself. And ultimately, this is connected through API systems, which means that everything is open. You can really retrieve and get information out of it. There is also one additional element that will be indicated in a later stage when we're going to connect this to the public system. So this is how the DOM wizard looks like. Essentially, you create a project into DOM wizard. You use the DOM knowledge model, and for each of those questions, you have direct information that you can type in. This information can be used by the original authors of the paper or by a curator and the information is ultimately pushed into the registry, awaiting sort of review to make it publicly available through the registry itself. This curation process is also recognized in the Curon, so it's a closed system that goes from end to end, from the data deposition to the data presentation through the registry and the user recognition of their efforts. The Curon itself, as I mentioned before, is the way that we can identify and recognize the people. And as you can see on the lower right hand, the number of contributions that have been done in annotating lists in the DOM registry are being captured here. So you can have kind of medals, badges, an actual number that you can go around and brag, I did that many annotation itself. Originally, the Curon has been primarily used for biocuration activities in databases, but the DOM registry is still the database, so the process still plays the same. And with that, I definitely need to acknowledge the people who were really behind all this effort, and that was not me by any kind of mechanism. Silvio Tosado is the lead of the group, Alex Bonzon, Damiano Clementel, and Omar Tafi. All of them were really driving the implementation and the connections all this together. And I think with that, I can share my screen once more to go for the last part, which is a pre-recorded version of the presentation from Scott Edmonds from GigaScience.
And thanks for having me. I am calling in from Borneo. So I'm going to present a different use case, as Fotis said, but using DOM in the wild really for another application, specifically for publishing. And publishing using it with papers that use machine learning, which is a growing amount, really. So it was great that we started off with the Menti that looked at people's interest, and reproducibility came up as kind of the number one subject. So I'm kind of preaching to the converted here. That we know that there's a challenge. There's arguments over how big an issue it is, but we know it is an issue. The worst case scenario highlighted in some papers, there is replication rates, at least in preclinical cancer research, as low as 11%. Different fields, not quite so bad, but it's definitely a major issue that we need to tackle. For it's a massive waste of money, bad drugs, bad holding science back really. And so this was a lot of the rationale for GigaScience and GigaScience Press. I'm the editor-in-chief of GigaScience, and we really set ourselves up at the beginning. We launched in 2012, really trying to be a journal for open science, really, to reward the additional efforts to share all of the underlying data, software, computational workflows. We were the first journal in biomedical sciences publishing data papers, for example, and peer reviewing this, crediting this, and trying to make reproducibility the kind of key here. And the other thing that we've been offering really is and are quite unique, is that we almost do open science as a service, because to make this kind of reproducible publishing really work, we have humans on hand. We have a curation team who, as part of the publication process, can basically go through the paper and help check and help the authors curate and make sure that all of the underlying research objects are available. If there is not a subject-specific repository, and not if things are intermediate data types or things are kind of falling through the gaps, we even have our own data repository that since 2011 we've been working with DataCite and give these data sets DOIs, digital object identifiers, that are then cited inside the paper. So this is all, reproducibility has been our big focus. We've done, a reasonable job, but these things are never 100% perfect, but at least pushing the kind of boundaries of kind of what you can do, and tackle this challenge. But as we've seen in the talks so far, the really big challenge in recent years has been the rise of machine learning, that has really facilitated so much research. But as the talks earlier mentioned, there's problems with a lack of evaluation, and black boxes, really. Proprietary tools. It's just, it works really well, but if you can't really figure out the inputs, the outputs, it's potentially a step back for reproducibility. Almost a big iceberg has suddenly hit us, and we've seen a huge rise in the submissions that we get. Photos showed the graph of the explosion in publications mentioning machine learning. So we're not the only journal that are kind of on the front line and having to deal with this. So we've had to really try and change our review process, really try to figure out how to tackle this challenge. So in medical research, there's been as with this explosion in machine learning, there's been an explosion in at least machine learning checklists, AI checklists and reporting guidelines, because so many of these things are basically going into the clinic now. And in medicine, they've been very specialized on particular data types of medical imaging, different styles of and like kind of add-ons to lots of the clinical checklists that are already out there. And if anything, there may be too many standards there. We really need broader and more general field agnostic guidelines, for biological sciences for one, and many other fields, but beyond these medical areas. And they're focused on, but these ones are focused on taking things into the clinic. They're very focused on authors, but journals and the peer review process has slightly different needs. And we want these things to be comprehensive, but not so difficult that it puts people off, and just get unwieldy. And any ways of integrating this with kind of online tools make the process easier, and also super useful. So we've been having this issue for a couple of years now, and thankfully Dome has come along. We were very happy to read the paper, and so we've been working with the group here and participating in a lot of the working groups and stuff, to try to see how it works. It's a bit of a trial, really. These are kind of early days, but it's given us actually a tool to that we can at least frame our peer review and this process. It may not be perfect. We may need to kind of tweak things, but it's great we actually have some kind of structure, something to work for. And so as a journal editor, it's been a great initial tool for the very beginning of the process. So a machine learning paper will come in, and as Photos mentioned, many of these have no evaluation, many of these have no data, or in some kind of gray area where it's kind of difficult to tell what is there, because they haven't really been thinking about the reproducibility side. So the editors kind of look and say, well, does it follow Dome? Very few papers so far are already citing it, but does it? We kind of asked the first question: does it look like it's kind of potentially domeable? If it has no chance at all, there's just no data, nothing to review, then we immediately reject it. And so it's been a useful tool in this kind of initial triage discussion. If it looks potentially domable, then we may go back to the authors, send them the DOME paper, send them the DOME checklist, and say, look, could you add like a few more details here? If it looks close enough, you know, at this stage we're not peer reviewing things, but if it looks like we're getting close, then we send it to the next stage to our data curators. They then have the DOME data stewardship wizard, and will work with the authors to then fill out these annotations. If you know lots of things are missing, there can be some back and forth, but hopefully you know we have a pretty full checklist there, and then we can go to peer review. And having everything in the wizard then actually aids the peer review process, making things easier for the authors as well and the reviewers, that it in a more structured way explains where all of the key parts of the study are. If it then passes peer review, then we can integrate the annotation into the publication. So what does the end product look like? So we will highlight the DOME annotations at the end of the paper in the data availability section. These can link out to the GigaDB entry that we create, and there's a link to the wizard in here. And if you click on that, then you basically see the DOME annotations in the data stewardship wizard website. So this is here for, so the reviewers could scrutinize this once it's published. The readers can scrutinize this. If there's a particular part that you're interested in, you can basically go through this and figure out, okay, where is the data, where are the models, how have they optimized and evaluated this? So it they may have missed describing these things in detail in the paper, but it's actually, at least it's here in the associated DOME file. So this is work in progress, but we're definitely seeing that this has been a very useful tool for us. The annotations are super useful for peer review, super useful for the editors, for the future readers as well, to properly understand papers. We've had about 20 papers go through this whole process now. We're currently using everything in the data steward wizard, but hopefully it will end up in the registry. And we would like to thank DOME for providing these fantastic tools, being great partners in this. I should thank our data team, our editorial team, and particularly Chris Armit, who was in the GigaDB team and did most of the heavy lifting here. The Elixir machine learning focus group, and all of the authors and reviewers who have used this. So, all right, I found the unmute button. So I think that was it. I have a very quick kind of note. Since the very few months actually that this was recorded, we have further improved the connection between DOME and GigaScience, and now all the published papers in GigaScience that have been gone through the annotation process are linked directly in the DOME registry and be findable through the DOME registry, and the information on DOME registry is linked direct to the published paper. So this is the full cycle now is in place, and we're trying now to improve both the experience of the reviewers as well as the authors to make this as streamlined as possible. And with that, I think I can stop here and to see if there are any questions that I can help with.
Thanks very much for this. And we can start with these questions. Are you considering similar standards for generative AI?
Thank you. Thanks for the question. The short answer is that yes, we are looking at adaptations, expansions of the DOME recommendations to other kind of methodologies. As I mentioned, DOME is defined predominantly for supervised learning. As such, there are some aspects in unsupervised or neural networks or generative AI that have particularities that are not yet evident in DOM. We are working in that direction, but generative AI by itself has a complete different set of constraints. So we are quite excited to see how this may look like in the expanded version of DOM.
Thank you. Another question, how does DOM connect with FAIR for machine learning?
Right. Thanks. So I'm sure everyone knows what FAIR is about. FAIR is findable, accessible, developable, and usable. So the main argument that we're using is that DOM is a facilitator of fairness. If you're following the DOM recommendation, if you're reporting on your process using DOM recommendation, it doesn't necessarily mean that your process is going to be fair. However, by providing information on the process, on the data, the model, the algorithm, the evaluation, in a way that follows the FAIR principles, ultimately it makes the whole process fair. So it's a facilitator of fairness by itself, but it's not that DOM equals fair by any kind of means. It's a reporting mechanism.
And how can the DOM registry be used to annotate articles?
So as was shown earlier by Scott and slide by Silvio, the DOM registry is essentially a database. It's a repository. So the DOM registry by itself is where the information is going to be deposited, is going to be available. Because it has an API, that's a completely sidetrack before I go back to the original question, it means that people can download information from there and do further analysis, do assessment, do everything else they might want to. The input system to the registry is essentially through the DOM wizard, which is also linked on DOM registry. So if you go to DOM registry, there's kind of submit, and this links directly to the DOM wizard. This means that you can go right in and provide annotation back into the system, or as a curator, request to update information to further refine the annotation that's already existing in DOM registry. So through these three services, the DOM wizard, Apicuron, and the DOM registry, essentially we allow and we enable people to go right in and further improve the annotation, or put their own papers and their own annotation in the system. This is very much encouraged because it will increase the number, the value increase the transparency of literature machine learning as much as we can.
Another question, does DOM help with machine learning reproducibility, and is it a requirement?
Right. That's a bit of a slightly trickier question. I kind of alluded to it while I was talking, so I really appreciate the question. In order to be able to reproduce machine learning, it's the equivalent if I want to be able to reproduce a software output. It's not sufficient to only have the code in the software. You also need to have access to the infrastructure to be able to run this. So if we go and review this from the DOM point of view, DOM, following all the annotation of DOM, one will have access to all this information on how to reproduce it. However, having the information and actually reproducing it requires kind of additional steps in between. It means that you need to be able to have access to the software. This is described in there because there's a question about what is the software. It might not be available, or you might not have access to it because it's a commercial or a proprietary one. This is not impossible. Even if you have the software, then the question is if the execution time and the resources are something that is accessible to the person who wants to reproduce that. The example I gave before is that if you need to have the entire HPC, the local HPC to your disposal for a month, you might be able to reproduce it. I'm not saying that you're going to be able to do it like period. If it's a smaller model, you might be able to do it in the first place, but then it comes back down to whether effectively a machine learning process can be reproduced, generally speaking, which is a huge challenge not yet solved as far as I know.
So you mentioned earlier that GigaScience is now adhered to the DOM recommendations. Do you think that there will be a day where all journals will adhere to this recommendation and maybe it will actually be a requirement for being able to publish?
Well, that will be the vision, right? Right now, GigaScience is essentially a trailblazer. Reporting on the process of the machine learning using the DOM recommendation is a requirement, as was mentioned also earlier by Scott. The idea is that this will show the way to other journals, to other venues, to use this as a reporting mechanism. And I would not limit this only to publishers. If we do the exact same mental exercise with data and data availability, right now, I think it is expected that if you submit an article for peer review, there is a question of where's the data? I want to be able to access the data at the very least to verify what you're saying is true. This is also part of a funding schemes, funding proposals. Occasionally, in some cases, also at the government level, you're expected to do that. I'm hoping, and that's a very personal hope, as you can imagine, that a similar situation might happen to machine learning. For me, ideally, that would be done. But even if it's not done for whatever reason, because again, it's a standard, there are a lot of standards out there, it would be absolutely critical in my mind that the same level of transparency that we have for data and data availability is also made equally central and expected for machine learning.
Thank you for this. We'll leave it here for today. Thank you once again for taking this time to talk to us. So as I mentioned earlier, this webinar is part of a series of bioinformatics training events organized by Australian Biocommons. You can find out more about upcoming webinars, workshops, and other events on our website and watch recordings of previous events on our YouTube channel. And finally, we'd like to acknowledge our funding. The Australian Biocommons is enabled by NCRIS via Bioplatforms Australia. And thanks so much for watching, and we hope you enjoyed today's presentation and look forward to seeing you again soon. And until next time, goodbye for now.